Hi, I'm Tom, coming to you from the International Institute for the Advancement of Sourdough Science and Research of Cleveland, Ohio, also known as my kitchen. Thank you for selecting this video. Today's video is the 8th episode in the series, When is Bulk Fermentation Done? In this series, we try to tackle the most complicated part of sourdough baking, especially for beginners, and that is trying to understand all the variables that impact bulk fermentation to help determine when bulk fermentation is finished. Now in today's episode, we will tackle one of the most confounding aspects of bulk fermentation, and that is answering the question, how can two recipes call for vastly different percent rises in the dough in bulk fermentation and come out with similar results at the end? Now, for example, in all the experiments we do here at the Institute, I use Chad Robertson's basic country loaf recipe. This calls for a 20 to 30% rise in the dough during bulk fermentation. There are other recipes that call for a doubling of the dough or a 100% rise in the dough, and they make equally good looking and great tasting loaves of bread. How is this possible? This is one of the most confusing aspects of reading sourdough recipes and really understanding when to cut off bulk fermentation, because you'll see these wildly different recommendations for the percent rise in the dough to signal the end of bulk fermentation. So in today's experiment, we're basically going to tackle this question. So with all of our experiments here at the Institute, we always start with doing some background research. So I looked at a number of recipes, probably 20 different sourdough recipes, and looked at the recommended percent rise in those recipes, and it's all over the map. So what I did is I found 3 recipes that we will look at today and compare these to Chad Robertson's basic country loaf recipe in Tartine bread. As I said, 30% rise recommended in Tartine. And then I have 3 recipes here, 2 that call for a doubling of the dough and 1 that calls for at least a doubling and preferably a tripling of the volume of the dough in bulk fermentation. They all make loaves that look almost identical. How is this possible? So as I looked at all these different recipes, I started to find one significant difference that may explain the difference in the percent rise, and that is temperature. The bulk fermentation temperature that's recommended is highly correlated with the percent rise that's recommended to end bulk fermentation. For example, Tartine bread recommends a 20 to 30% rise in the dough. The recommended bulk fermentation dough temperature is 78 to 82 degrees Fahrenheit. That's fairly warm. That's 5.5 to 28 degrees Celsius. When you compare these other recipes, the recommended rise is typically doubling or more, and the recommended temperature in every one of these recipes is lower than 21 degrees Celsius or 70 degrees Fahrenheit. So that's a significant difference. So my hypothesis is that the percent rise in the dough in bulk fermentation is highly correlated with the bulk fermentation temperature. So in today's experiment, we're going to try to prove that. So just for comparison to Tartine, which calls for that bulk fermentation of 78 to 82 degrees Fahrenheit or 25.5 to 28 degrees Celsius, there are 3 other recipes that I looked at that all fall in a similar range. One is Emily Raffa from the Clever Carrot. Her beginning sourdough recipe recommends a doubling in the dough, and it recommends a bulk fermentation temperature of 68 to 70 degrees Fahrenheit or 20 to 21 degrees Celsius. I also looked at Elaine Boddy's master recipe from the Food Bod website. Her recipe calls for a doubling of the dough and even cooler, 64 to 68 degrees Fahrenheit or 18 to 20 degrees Celsius. That's a very cool overnight bulk fermentation recommendation. The third recipe is from Ken Forkish, and this is from his overnight country blonde recipe from the book Flour, Water, Salt, Yeast. He calls for a tripling in the volume of the dough in an overnight bulk fermentation. He does not give a specific overnight bulk fermentation temperature, but he mentions throughout the recipe that his room temperature during the day presumably is 70 degrees Fahrenheit. So we can presume that the overnight temperature is 70 degrees Fahrenheit or less. That would be 21 degrees Celsius. And he calls for a 12 to 15 hour bulk fermentation. So when you compare all of these recipes that are calling for a doubling or more, of the dough volume during bulk fermentation, all these temperatures are below 70 degrees Fahrenheit. Now for today's experiment, I'm going to follow the tartine recipe, but I'm going to bake 4 loaves of bread and bulk ferment all of them at 70 degrees Fahrenheit or 21 degrees Celsius. What I'm going to do differently is I'll let one of those loaves rise 30%, which is what the tartine recipe would recommend. We'll do one at a 50% rise, one at a 75% rise, and one at a doubling or 100% rise. And then we'll bake all those up tomorrow, and when we cut them open, we'll compare the crumb of those 4 different percent rise to I have hundreds of examples of what the tartine crumb typically looks like, and then we'll be able to determine what that benchmark is to say if you're going from 80 degrees Fahrenheit at a 30% rise, what is the equivalent percent rise at 70 degrees Fahrenheit or 21 degrees Celsius to get the exact same looking crumb. That's the experiment. Now for today's experiment, like all the experiments that I do, I'll be following the Tartine Basic Country Loaf recipe. If you're not familiar with this recipe, you can download it from the Tartine Bakery website. The only thing that we're going to change is the bulk fermentation temperature and the recommended percent rise. Now one of the added benefits of doing this experiment is that we will also be able to test the incredible Bulk-O-Matic system. If you're not familiar with this tool, we developed this here at the Institute, and this was launched in episode 3 of this series. So you might want to go back and watch that first to understand how we use this tool. But it's basically a 9 criteria test to determine when bulk fermentation is done. However, this tool is specifically calibrated for the tartine recipe. So it's calibrated for the 80 degree Fahrenheit, 27 degrees Celsius bulk fermentation temperature, and the times are also calibrated based on that temperature. So what we'll be doing here today is ignoring the recommended temperature and time because we're using a different temperature, 70 degrees Fahrenheit, 21 degrees Celsius. The time is going to be whatever it takes to get that percent rise, and we're also ignoring the recommended percent rise of 30% for 3 of the 4 loaves. So we're basically significantly changing up some of the variables here, but I still want to use this tool so that at each one of those loaves being cut off at 30% rise, 50% rise, 75% rise, and a doubling, we'll compare the other 6 criteria to say what does the dough look like, what does it feel like, what does it smell like, again, to try to calibrate what a 70 degree Fahrenheit, 21 degrees Celsius bulk fermented loaf should look like, feel like, and smell like. Then we can have a different version of the tool for a 70 degree loaf. So now let me recap the details of the recipe if you're not familiar with it. The reason I include all of this in my videos is because I want these videos to be scientifically repeatable experiments so that if you follow these exact steps at home, using the same ingredients, using the recipe, I provide all the details here so that you can produce exactly the same outcome that I'm producing. There are very few videos like this, and that's part of the reason these videos are long, is because I don't leave out anything that's germane to the outcome of the experiment. It's all here. So in today's experiment, I'm using the same flour that I've used in all 7 of the prior videos. It's 90% bread flour, 10% whole wheat flour that's called for in the recipe. The 90% bread flour I split in half. So 45% of my total flour is the Central Milling Company High Mountain High Gluten flour. 45% of the total is Central Milling Company Artisan Baker's Craft Plus. And 10% is King Arthur whole wheat organic flour. Those are the same flours I use all the time. We start with that 1,000 grams of flour, then we add 750 grams of water, 200 grams of leaven, and 20 grams of salt. So in the baker's percentages, it's 75% water, 20% leaven, 2% salt. I follow all the steps in the recipe exactly by the book. If I deviate from any of those, I'll let you know. And here's the summary of the recipe. I'll put that up on the screen so you can pause here if you want to look at that in more detail. So the question for today's experiment is how can you have a different percentage rise in the dough in bulk fermentation and come out with the same results? And the hypothesis is that because the temperature is different in bulk fermentation, lower temperature bulk fermentations can handle a higher percent rise in the dough. That's really what we're going to try to prove here today. Now, when I've done experiments in the past, I can say anecdotally, I have definitely seen this. When you bulk ferment dough at lower temperatures, the dough remains stiffer and it just has a firmer architecture than warm dough. It's like any other food that you're cooking in your kitchen. When you heat things up, they tend to relax, they tend to flatten out. The same thing is happening with the dough. And even though these temperature ranges are much lower than the ranges you would typically be cooking at, the fermentation process is essentially cooking the dough. So we're basically saying that the 70-degree Fahrenheit loaf, 21 degrees Celsius, that dough is cooking at a lower temperature than the recommended 80-degree Fahrenheit, 27 degrees Celsius loaf in Tartine, which is cooking at a higher temperature. So if I'm cooking something at a higher temperature, I would expect it to be softer, more relaxed, and flatter. And that's essentially what I believe is happening here. It's just that basic chemistry of the molecules are moving more rapidly at higher temperatures that's causing the gluten to relax, and that allows the cooler loaf to rise more than the warm loaf where the gluten matrix is more relaxed. Now, in addition to the temperature differences impacting the architecture of the dough or the stiffness of the gluten matrix, the ability to hold more air in a higher structure versus a flatter structure in the more relaxed, warmer dough, the other thing that happens when you bulk ferment at higher temperatures is you're also changing the chemistry of the dough. When you start to bulk ferment at 80 degrees Fahrenheit or 27 degrees Celsius, for example, you start to favor the lactic acid bacteria more than at lower temperatures, and it raises the acidity of the dough. When you raise the acidity of the dough, that stimulates something called the protease enzyme. The protease enzyme eats gluten and it starts to break down the gluten matrix. So as your temperature increases, the acidity increases, and that protease enzyme reaction increases. So essentially it's flattening the gluten matrix. It's kind of like you're trying to build a house at a warm temperature, but the termites are eating the house from the bottom up. So when you're building the third floor, they've eaten the first floor and you're already back down to a 2-story building. That is exaggerated at higher temperatures. The protease enzyme is particularly exaggerated when you get up to 90 degrees Fahrenheit or 32 degrees Celsius, which is really the highest meaningful bulk fermentation temperature you can really operate at. That's where you see significant gluten deterioration because of the effect of the protease enzyme. That's happening in the 80-degree loaf as well, 27 degrees Celsius, just not as fast or as evident as it's happening in that warmer loaf. So as the loaf is trying to rise, the warm temperature of an 80-degree loaf relaxes the gluten, so it just slumps the dough down a little bit, and the protease enzyme starts to eat the gluten, so no matter how hard the yeast works, it is not able to inflate the matrix because the enzyme is popping the balloons that the yeast is trying to inflate. Now let me try to demonstrate this impact that temperature has on the gluten matrix through something that I call the Linguini example. So when you're trying to understand how the temperature could impact the percent rise, for me it's helpful to have a visual to show what does the gluten look like at different temperatures. So for that reason, I created the Linguini example. And yes, I just came up with this a few minutes ago. So basically what I did is I took 20 strands of linguini. I boiled one batch of them for about 3 minutes, another one for 9 minutes, and another for 15 minutes. And what I'm trying to demonstrate here is what do the gluten strands look like and feel like at different dough temperatures. So our 70-degree Fahrenheit, 21-degree loaf would look kind of like this. That's the al dente. That still has a lot of structure. It's still very firm. When you get up to 80 degrees Fahrenheit or 27 degrees Celsius, this is pretty soft and your dough will start to relax more. So this is just based on that temperature. You see that relaxation of the dough. And then at 90 degrees Fahrenheit, the dough is as relaxed as it is in the 80-degree loaf or the 27 degrees Celsius. Now we're up to 32 degrees Celsius. But the other thing that happens at 90 degrees Fahrenheit is you release the protease enzyme. The protease enzyme is the uninvited party guest that comes along with the lactic acid bacteria this is the protease enzyme. So what happens when you get up to 90 degrees Fahrenheit or 32 degrees Celsius and you're trying to do bulk fermentation, the protease enzyme comes to the party and it breaks the gluten strands. It eats the gluten. It loves the taste of the gluten matrix, and the protease enzyme really goes to town on your gluten. So now you have the baseline here of a 70-degree loaf, 80-degree loaf, 90-degree loaf. And now we try to understand why the cool temperature loaves would be taller when you think about that dough in bulk fermentation than the warm temperature loaves. So now let me move these into a vessel and we'll see how tall they look. So now I've transferred the linguini into these 3 beakers so that we can envision what does the gluten architecture look like? What does the gluten matrix look like at different temperatures? At low temperatures, the gluten matrix is tall. I mean, it just keeps that architecture. It's because it doesn't relax as much at low temperatures. When you get up to 80 degrees Fahrenheit, 27 degrees Celsius, the gluten relaxes. It just sits down in the bowl. You can still make perfectly good bread with that, and the yeast will still fill the gluten matrix, but the gluten matrix is just softer at warmer temperatures. And when you get up to 90 degrees Fahrenheit or 32 degrees Celsius, you have a very flat gluten matrix, and your gluten strands have also broken down because of the protease enzyme. This is what overproofing looks like, is a flat loaf with deteriorated gluten. So that's an example just to show the visual, and this makes perfect sense. If you went to a county fair and they were having a contest to see how high you could stack a ball of dough, and you had an option to take the 70-degree ball of dough or the 80-degree ball of dough, you're going to take the 70-degree ball of dough because it's stiffer. It just makes perfect sense. I'm really going on and on about this, but it's kind of frustrating because in all the time that I've spent studying sourdough and baking sourdough and reading recipes, nobody has ever really come out and said this, that when you bulk ferment at low temperatures, you'll get a higher % rise than bulk fermenting at warmer temperatures, and you could produce exactly the same loaf at the end. The dough, before it's baked, just happens to be more relaxed at warmer temperatures. Now, we really haven't proven anything. This is really just a statement of our hypothesis, but when you ask the question now and say, how can a 70-degree loaf bulk ferment and double in volume, and how can an 80-degree loaf bulk ferment and rise 30% in volume, that's a pretty good indication right there. And the thing to remember is the number of gluten strands are exactly the same. So these can still produce the exact same loaf in the end. The gluten matrix has the same number of cells. The warmer temperature gluten matrix is just more relaxed than the cooler temperature gluten matrix during bulk fermentation. But these 2 loaves could bake up exactly the same way. That's what we hope to prove in this example. In the interest of time, I've mixed all the ingredients off camera. As I've mentioned, I follow the tartine recipe by the book. You can see all the detailed steps in many of my other videos, but I'll point out a few things just so we have the full documentation in this video for the record. So I always like to make some note of what my leaven or my starter looked like, because in one of my recent videos, we showed that whether you're using a strong starter or a weak starter can materially impact your bulk fermentation time. And even though we're not really precisely doing an experiment on bulk fermentation time here, I do like to have a record of that. So I made the leaven per the recipe last night. It's essentially a 1-10-10 feeding of your starter using a 50-50 mix of bread flour and whole wheat flour. In the morning, the leaven had risen, I'd say about 50%. It was bubbly on the sides, but it hadn't quite risen as much as I expected it to, and there were no bubbles on the top, and it still didn't really have that ripe smell. So I let it go 12 hours from when I initially mixed it. My kitchen temperature was relatively cool last night, which is 69 degrees Fahrenheit. That's 20.6 degrees Celsius. So after 12 hours, the leaven looked really good. It had about doubled in height in the vessel. Here's a video of what the leaven looked like the next morning. I also did a float test. There's a lot of controversy about whether the float test works or not, but if you follow this recipe, the float test is reliable and it's recommended in the book. So I did the float test. You could see here a really nice float of my leaven. And then lastly, here's just a quick video of the leaven being poured out into the bowl. Again, just to document some of these characteristics of the leaven, because the leaven strength can have such an impact on the bulk fermentation of the dough. After I added the starter, you add in 700 grams of water. Now this is where I had to make a decision as to whether I continue to follow the Tartine recipe, which calls for 80-degree Fahrenheit water, which is 27 degrees Celsius. I did decide to do that because I wanted to give this a little bit of a jump start. I could have mixed this entire batch of dough at 70 degrees Fahrenheit or 21 degrees Celsius. It could have taken 14 or longer hours for this to double. So because I don't want to be up in the middle of the night making this video, I followed the Tartine recipe with the water temperature. It maybe gave this a little bit of a jump start, but since then I have had my room temperature at between 69 and 70 degrees Fahrenheit. It's cool in here. It's about 21 degrees Celsius, 20 degrees Celsius. I have my doors and windows open here. It's early spring in Cleveland, so if you hear the birds outside, or we have a couple of geese out here in the back that like to announce their arrival and departure, you might hear some different background sounds here today. After we mix the dough, we do a 30-minute autolyse. Again, that's at room temperature, but the dough temperature was still in the high 70s. During the autolyse, we were at 77 degrees Fahrenheit dough temperature. That's 25 degrees Celsius, so a little bit of a jump start, as I mentioned. Then we add 20 grams of salt, 50 grams of reserved water, mix that up again. That dropped my temperature down to 76 degrees Fahrenheit or 24 degrees Celsius. Then I started doing stretch and folds every 30 minutes on the countertop here. I'm on the 4th stretch and fold right now. We're doing these at 30-minute intervals. My room temperature is 69 degrees Fahrenheit, 20 degrees Celsius. My dough temperature is still at 71 degrees Fahrenheit. I want to get this down to 70. It'll be there momentarily. That's 22 degrees Celsius. So at the 4th stretch and fold, let's say we're roughly at the 70-degree bulk fermentation temperature. I'm going to do the 4th stretch and fold. I'm going to see how this feels. I might do a 5th one. Then we're just going to pause and I'll divide this into 4 separate bowls, and then we're going to look for the first one to rise 30%, and that'll be our first cutoff point. And we'll compare that 30% rise and all the other Bulk-O-Matic criteria to see what a 30% rise loaf looks like at 70 degrees Fahrenheit or 21 degrees Celsius, because the 30% rise is the recommended rise in the Tartine book. Based on our hypothesis, that loaf is likely going to be underproofed because you're getting a little false sense of that rise at a lower temperature because the dough is stiffer, but we don't know until we try it out and see if we can prove that. So I'm going to continue to do all this off camera. I'll come back when we get to that first batch of dough at the 30% rise, and we'll do the Bulk-O-Matic test. So while we're waiting for the dough to rise, I just wanted to take this opportunity to introduce you to my production crew. Now here at the Institute, we have a state-of-the-art facility for recording these videos, and I'm the person on the camera that gets all the credit, but I really have a tremendous team of people behind the scenes making all this happen. So I wanted to take this opportunity to introduce you to my hardworking crew. First, we have my sound engineer, Rodney, holding up the boom mic there. He always makes me sound good. Next, we have my cinematographer, Mickey. You can see he only uses state-of-the-art recording equipment for all of our video. The third member of our crew here is Jason. Jason's our video editor. He really works a miracle on the computer there, making all this stuff look good. And then lastly, but certainly not least, is our director, the brains behind the operation, Jean-Luc. Jean, say hello to the camera. That guy's really a piece of work, but I love him like a brother. Some people say we even look like brothers, but honestly, I don't see the resemblance. Thanks for meeting my crew. Let's get back to making some bread. It's been 7 hours since we mixed the dough. There's not much happening here yet, but what I'm going to suggest is let's go through the 9 criteria of the Bulk-O-Matic test and see where we are. Because this is the point where you start second-guessing yourself. Your mind starts playing tricks on you. You think you messed up the ingredients. You think you forgot to add your starter. Maybe something was wrong with your leaven. Just go through the test. Let's do the 9 criteria and just see where we are. Now, the reason I'm not too worried about this, even though this is a long time for me because I generally do shorter bulk fermentations, is because I know from all my experience that bulk fermentation follows a curve that looks like this. It nothing happens up front. Very, very slow, 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 slow. Then it gets to a point and boom, you get the hockey stick at the end, where a lot of activity happens at the very end of the bulk fermentation process. At 70 degrees Fahrenheit, this could be a 10 to 12 hour process. That means that the vast majority of the rise might occur in the last 90 minutes. It's usually in the last 15 to 20% of the full bulk fermentation time is when you see that big move at the end. So we still have a little ways to go. But I like to look at the dough. I like to smell it. I want to get my hands on it and just get some data points here to see where we are at the 7 hour mark. So first, our temperature, we are at 70 degrees Fahrenheit is my room temperature, exactly where we want to be. The dough temperature, this one's at 69. This one's at 69. That one's at 69. That one's at 69. So our temperature is 20.6 degrees Celsius, 69 degrees Fahrenheit, 1 degree below where we want to be, very much in the ballpark. Our time is at 7 hours. I'm just guessing based on some of the guidance that we saw in the recipes, this could take 10, 12, 14 hours for these to rise. So we're still early. The percent rise, if I look at my marker on my bowls, I have these marked on my side in milliliters. They are above the starting point. I'd say they're at about, I don't know, maybe a 10% rise right now, pretty consistently across all 4 of these. Are they domed on top? They are domed a little bit on top. You can definitely see some fermentation activity happening in these, so I know that I didn't forget to add my leaven. I know that my leaven is working. Are there bubbles on the top? I see a little bit of bubble activity, 1, 2, 3. That indicates that there's some fermentation happening, but we're nowhere near done. Are there bubbles on the sides? Now this is really usually a good indicator of how far along we are. There are very few bubbles on the side of these. This dough still looks really flat to me. I'm a little bit surprised that we're not seeing more bubble activity on the side. That just means this is still super early. Then I do what I call the wobble test. What I do is I like to shake the bowl and see how that dough moves in the bowl. And if it starts what I call splashing against the sides of the bowl, that means that there's aeration in here. This is actually moving pretty well. So this isn't as stiff as I might have thought, but it's not loose and aerated. It doesn't feel like there's a lot of air in it. It just feels soft, is the way that I would describe that. Then I want to do a window pane test. I'm just going to randomly select one of these. They all should be the same. And the reason I do the window pane test is for 2 reasons. One is to ensure that we got sufficient gluten development when we were mixing the dough. That's a spectacular window pane right there. Look at that translucency right through that. It's not tearing at all. That's a superb window pane. So that means that we have sufficient gluten development from the stretching and folding and from the inherent gluten that's in the flour. And we're not seeing any evidence of gluten deterioration, which is the early indication of overproofing. So if you think for some reason your dough is overproofing, just do a window pane test. You'll feel it in your hands. If that window pane starts to tear, starts to fall apart, starts to rip, you know that the gluten is starting to deteriorate. That's going to happen very late in the process. I didn't expect it to happen here, but if you're ever nervous about it, just put your hands on the dough, do the window pane test. That's a super way to really feel where your dough is, really tactilely. Then lastly, we do the smell test, and this is really fascinating because in the Bulk-O-Matic test, there's a continuum of what I call floury smell, which is when you just mix the flour and water, you know that smell when you mix the dough. That's when you're really significantly underproofed. When the dough is fully proofed, it'll usually take on a very sweet smell, almost has a sugary smell to it. Some people call it a ripe smell. I call it more of a sugary sweet smell, at least with the flour that I use. And when you start to overproof the dough, it'll start to smell like your starter. You'll smell that vinegar smell coming out of it, or maybe a little bit of alcohol smell, but primarily vinegar. What I'm smelling here in this dough is actually the sweet smell that I usually, it's not quite there, but it's tending towards the sweet smell that I usually smell in the 80 degree Fahrenheit or 27 degrees Celsius bulk fermentation when the dough is really nearing the end of bulk fermentation. So this is really fascinating because just based on the smell, this feels like it's really far along, but none of the other variables are there. The rise, the bubbles, etc. So that smell is interestingly a potential false indicator at these low temperatures, because that definitely is leaning towards the ripe, sweet smell that I look for. So that's where we are with the test right now. I'll put this up on the screen just so we have a record of where we are at this point. We still have a ways to go. I'll check in here from time to time and we'll see if things start moving. Here are the details of the Bulk-O-Matic chart at 7 hours. It has been 9.5 hours since we mixed the dough. Loaf number 1 is at the 30% rise mark. So what we want to do now is we'll go through the 9 criteria on the Bulk-O-Matic system. And what I want to do is compare a 30% rise at 70 degrees Fahrenheit or 21 degrees Celsius to a 30% rise at the normal tartine recipe, which would be 80 degrees Fahrenheit, 27 degrees Celsius. So let's go through the test. So obviously temperature, we've been right at where we want to be, 70 degrees Fahrenheit, 21 degrees Celsius. That's been our target. We started out a little higher, we went a little under. I'm going to call that right at 70. The time, 9.5 hours. Now that compares to the 80 degree loaf. The tartine loaf typically bulk ferments in about 4.5 hours. So we are, more than double the amount of time to get to that same 30% rise, which is a bit surprising for a 10 degree Fahrenheit difference. That's about 6 degrees Celsius difference, that it would take twice as much time. It's interesting. I don't know what else to say about it at this point. The percent rise, we're cutting it off at 30. That's usually the high end of the range for tartine. Then we do the other criteria. Is the dough domed on top? Slightly. There's a slight shoulder around the edges, not as pronounced as I normally would see. Are there bubbles on the top? Very, very few. Are there bubbles on the sides? More than there were before, but fewer than we normally would see in bulk fermentation at this point. The wobble test, that dough is somewhat loose, but yeah, not quite as aerated as it should be, but I would call that somewhat loose. It's shaking pretty nicely. The window pane test, we're really just doing this now to make sure that we're not heading into overproofing, which I don't think we are. Still a really superb window pane. So that says that this dough has further to go. Like you could really let this continue to ferment without any risk of overproofing based on the strength of that window pane. And then the smell test, I'm looking for that sweet smell that I smell in the peak point of bulk fermentation. It's just slightly to the left of that. I'm still smelling a hint of the flour smell, not the total sweet smell that I'm looking for. So other than the percent rise, all other indications are that this loaf is not finished with bulk fermentation. But we're really honing in on the percent rise so that we can do a strict comparison of a 30% rise of a 70 degree loaf to a 30% rise of an 80 degree loaf. And this is just an indicator of what we'll probably see when we bake this up. We never really know until we bake it and slice the loaves open. So I'm going to call this done, even though our indicators are saying that this is likely underproofed. This is what a 30% rise loaf at 70 degrees Fahrenheit, 21 degrees Celsius looks like. Here are the Bulk-O-Matic details for loaf number 1. We'll see how this bakes up tomorrow. You can pause here if you want to look at that in more detail. So if you haven't seen any of the 7 prior episodes in this series, let me describe what we do here because it's a little different. Because we're focused on the cutoff of bulk fermentation, I really want to assess the crumb really at this point in time if I could. So I don't do pre-shaping or final shaping because the shaping steps can introduce irregularity into the crumb that can sometimes be confused with overproofing or underproofing. So I basically take this loaf out of the bowl, I flop it into the shaping basket with no pre-shaping and no final shaping. I still let it rest on the countertop for 30 minutes because the bulk fermentation step is done, but according to the tartine recipe, which is our baseline for all the experiments, there's another 30-minute room temperature bench rest, so we have to do that to stay consistent with the baseline recipe. Then this goes into the refrigerator for an overnight cold retard, and then we'll bake it up in the morning. So I'm basically just going to take this out of the bowl right now and flop it into that shaping basket. Now I like to feel what this dough feels like as it's coming out of the bowl. This is stiff compared to what the dough usually feels like when it's coming out of the bowl. This is a little bit stiff in the middle. The edges of this actually feel kind of soft, but in the middle, I'm just feeling a very stiff mass of dough. Then I carefully scoop this out, and I do what I call the droop test. That's a pretty droopy loaf, so that's pretty far along, more than I expected. And then we flop that into the shaping basket. That's all we're going to do. And then once it's in the shaping basket, I like to shake it. Yeah, that dough is pretty far along actually. For a 30% rise, and based on the smell, that loaf looks pretty good. Even though, you know, a lot of the indications show that this might be underproofed, and I think it probably is. It's not seriously underproofed. That dough actually looks okay. So I'm not sure what's going to happen with the future loaves here. But this goes into the fridge for an overnight cold retard after a 30-minute bench rest. We'll bake it up tomorrow. So in the first part of this video, we asked the question, why do some recipes call for a 30% rise when others call for a 100% rise? And our hypothesis is that because those 100% rise recipes are bulk fermenting at a lower temperature, and at a lower temperature, the dough can just stand up to a taller rise. The architecture of the gluten structure is not as relaxed as a warm dough. That's our theory. There's another component that you have to think about to understand why certain recipes may cut off at 30% like Tartine versus 100% for the 3 samples that I talked about earlier in the video. So when a recipe designates the percent rise for bulk fermentation, you always have to think about what happens after the end of bulk fermentation. And this is part of the reason why Tartine calls for a 30% rise and it cuts it off seemingly really early. The reason is because in the Tartine recipe, after the 30% rise, where the dough temperature is still at roughly 80 degrees Fahrenheit or 27 degrees Celsius, you do pre-shaping and then you do a 30-minute bench rest. During that 30-minute bench rest between pre-shaping and final shaping, that dough is still actively fermenting at roughly 80 degrees Fahrenheit because that dough temperature does not change significantly once it's at that temperature. So I have 30 minutes of extra fermentation just because I called the end of bulk fermentation. The yeast doesn't know bulk fermentation's over. It's fermenting for 30 more minutes. And then when the dough goes into the refrigerator, here's a chart that I've shown in some other videos. This is from a sample that I did a couple of months ago where I put a continuous probe thermometer into a loaf to look at the temperature of the dough after the dough goes into the refrigerator. And what you see here was this dough went in at roughly 78 degrees Fahrenheit or 26 degrees Celsius. It took an hour for that dough to get down to 70 degrees Fahrenheit or 21 degrees Celsius, which is the temperature of this loaf. So now think about that comparison. In the Tartine loaf, we've been bulk fermenting at 80 degrees Fahrenheit. This one bulk fermented at 70 degrees Fahrenheit. At the end of the bulk fermentation step, the Tartine loaf goes another 30 minutes at 80 degrees. It's really smoking. That is a warm temperature. And then when it goes into the refrigerator, it's still above 70 degrees Fahrenheit for an hour. So for 90 minutes after the end of bulk fermentation, this loaf of bread is still fermenting more vigorously than this loaf. That's the reason for the 30% rise, because you're trying to stop a speeding train. When your dough is fermenting at 80 degrees Fahrenheit, 27 degrees Celsius or higher, you need to really slam on the brakes to get that to slow down. So that's the reason that it cuts off at 30%, is because you're hitting the brakes at 30 because it's bulk fermenting for 30 more minutes on the countertop and then another hour in the refrigerator before it gets to 70, which is the equivalent of this. But then it keeps fermenting even after that. If you look at this chart again, it takes 4 hours until the loaf gets down to 50 degrees Fahrenheit or 10 degrees Celsius. So the loaf is still actively fermenting in the refrigerator. But when you just compare the 2 loaves, 70 degrees versus 80 degrees, there's clearly an extra 90 minutes of fermentation at a very warm temperature in this loaf versus this loaf. That's the reason you get the early cutoff of the 30%. It has been 11 hours since we mixed the dough. Loaf number 2 is done. This is our 50% rise. We are just at 50% right now. Let's go through the 9 criteria on the Bulk-O-Matic system First, what's our temperature? Room temperature is 71 degrees Fahrenheit. The dough temperature is now at 71, so this has crept up a little bit. That's 22 degrees Celsius. We were shooting for a temperature of 70 degrees Fahrenheit. The percent rise, as I said, is 50%. That's higher than the typical recommended rise in the tartine recipe. Is the dough domed on top? It is. This is a little more domed than loaf number 1. You can see that shoulder around the edges when I tip the bowl like that. Are there bubbles on the top? Yes, there's one big bubble here, 1, 2, 3 small bubbles, so a little bit more vigorous bubble activity on the top of this one than the prior loaf. Are there bubbles on the side? Yes, this is where I'm seeing a significant difference compared to the prior loaf. It's a lot of small bubbles. Usually we'll see more big bubbles on the side, but just the number of the bubbles is much greater than loaf number 1. The wobble test. This is more loose and aerated than loaf number 1. I'd say this is more typical with what I would see in a loaf that looks like it's about done. Let's do the window pane test to see if we have any gluten deterioration. And we do not. That is still a fabulous, strong, translucent window pane after 11 hours. That's incredible. And lastly, the smell test. This is smelling more like that sweet smell that I'm looking for, still slightly to the left of it. I'm still smelling a hint of the flour smell and not that pure, sweet, sugary aroma that you almost taste on the tip of your tongue through your nasal cavity. So this is an interesting loaf at 50% rise. This looks a little bit more like the standard tartine loaf would be at 30% at the higher temperature, but this is still slightly under what I would expect based on the bubbles that I'm seeing on the side, the bubbles on the top. So we're still not quite there. So let me put this up on the screen so you have the details of the Bulk-O-Matic chart for this loaf. The fascinating thing here is that window pane. After 11 hours, we're still seeing no gluten deterioration at all. That is really the magic of fermenting at this low temperature of 70 degrees Fahrenheit, 21 degrees Celsius. At the higher temperature, we start to have gluten deterioration when we bulk ferment in tartine at 80 degrees Fahrenheit, 27 degrees Celsius. You'll get gluten deterioration after 5 hours. The dough will start breaking up in your hands, and that's because the acidity of the loaf increases with the temperature. The acidity stimulates the protease enzyme. The protease enzyme eats the gluten. The protease enzyme is asleep here. It's just not present because it's not breaking down the gluten. I don't see any evidence of it. So this is really, like I said, the magic of this low temperature fermentation is there's no gluten breakdown. Let's take this out of the bowl and get it into the shaping basket. Yeah, this feels more aerated than the prior loaf. I can just tell by the way it's pulling away from the sides. Then we scoop it out. Yeah, this dough is soft. There's our droop test. That looks very similar to what we would see with the 30% loaf at 80 degrees Fahrenheit with tartine. And then we do our shake test. That's a really nice shake. There's a lot of air in that dough, really nicely fermented. I think that would be a really nice looking loaf based on what I've typically seen in the past. That's a 50% rise. Okay, let's get this into the refrigerator. After I do the 30-minute bench rest, this will go into the fridge for the overnight cold retard. We'll bake it up tomorrow. It has been 12 hours since we mixed the dough. This is loaf number 3. This is done at a 75% rise. That's looking pretty good. So this is just 1 hour after loaf number 2. So as I mentioned earlier, there's kind of a hockey stick effect here with the bulk fermentation. Once it really starts moving, it starts moving very quickly. So nothing happened for 9.5 hours. Then we had loaf number 2 at 11 hours, loaf number 3 at 12 hours, and we'll see if loaf number 4 is right on the heels of this one. Let's do the Bulk-O-Matic test. Let's take the temperature. This dough temperature is at 69 degrees Fahrenheit versus our goal of 70. That's 20.6 degrees Celsius versus 21.1. So right where we want to be. This has really been very tight in that range the whole time. The time, as I mentioned, 12 hours since we initially mixed the dough. The percent rise is at 70%. Is the dough domed on top? Absolutely. You can see each one of these successive loaves is getting a higher rounder dome on the top. Are there bubbles on the top? Yes, I see 1, 2, 3, 4, 5 bubbles on the top of this one. That's more than we had on the others. Are there bubbles on the side? Yes, this is really the vigorous bubbling that I typically look for in bulk fermentation. You can see that on the side of the bowl. Let's do the wobble test. And you can see this loaf is loose and aerated. So this one looks very much like a nicely proofed loaf. The window pane tests our gluten. After 12 hours, typically we would see some gluten deterioration. Not with this dough. This is incredible. 12 hours and I'm not seeing any tearing of that dough. That is a spectacular window pane. It's unbelievable after 12 hours. As I said, that is really the magic of this low temperature bulk fermentation. There's no gluten deterioration at all. And then the smell, that's the sweet smell that I look for. All of these loaves, though, have been slightly left of center, if you will, slightly less of that sweet smell than I smell with the slightly warmer bulk fermentation at 80 degrees Fahrenheit or 27 degrees Celsius. It's just something a little bit different about that. We'll see how these bake up and how they taste. So let me put this up on the screen so you have the details of the Bulk-O-Matic chart for this loaf. Now let's see how this feels as I take it out of the bowl. Very nicely aerated loaf. Similar to the prior loaf, I'm seeing a little bit of those gluten strands around the edges, but they're pulling away pretty easily. It's not a real sticky loaf like I see when loaves start to overproof. This one feels slightly airier than the last one, which makes sense because it rose 25% more. There's our droop test. That still is not a bad looking loaf. These are not indicating any overproofing at all. Into the basket. The shake test, really beautiful. That looks like a really nicely proofed loaf. I think that one's going to bake up very nicely as well. I like the way that that's shaking right there. So this will go into the refrigerator for the overnight cold retard with the others, and we will bake this up in the morning. It has been 13 hours since we mixed the dough. Loaf number 4 is done. This has doubled in volume. It's right at a 100% rise. Now, one of my pet peeves with these recipes that call for a doubling of the dough is that people just try to eyeball it sometimes. There's no way you could just look at this bowl and tell the difference between 100% rise and 75% rise or 125% rise. You really have to measure it. And it can make a material difference, as I think we're going to see in this one. The difference between 75% and 100% was 1 hour difference. And this dough looks and feels a little bit different to me already. So let's go through the tests. Number 1 is our temperature, 70 degrees Fahrenheit, right on the target, 21.1 degrees Celsius, exactly where we wanted to be. We did a great job maintaining this temperature throughout, so I think this is a really great test at the target temperature. The time, 13 hours from the time we mixed the dough. The percent rise, 100% or doubling. Is it domed on top? This loaf is domed on top, but you can see it actually looks like it's flattening out a little bit around the edges compared to the last one. Are there bubbles on the top? This is peculiar because this had some bubbles on the top and they've deflated. So that implies that this one is starting to push towards overproofing a little bit. I don't actually see any bubbles on the top, and I know there were some on the top earlier. Are there bubbles on the side? There are. I would say this still has vigorous bubbling on one side, but the other side is starting to lose its bubbles. You see those tiny pinpoint bubbles on that side? So the bubbles on the side are deflating. The wobble test, loose and aerated. It's hard to tell anything good or bad about that. That's right down the middle. Really nice loose loaf, very aerated. Let's do the window pane. See how our gluten is standing up 13 hours after mixing the dough. Wow, still just incredible window panes pulling on this dough. Look at that. It is fabulous. Just never seen anything like that. 13 hours into bulk fermentation, no tearing at all. And then the smell test, very similar to the others, heading towards that sweet smell in the middle, but not quite as sweet as when I bulk fermented at warmer temperatures, still just slightly left of center. But this loaf still looks pretty good. Let's get it out of the bowl. I can't really tell where this is until I feel it. Now this is super aerated. It's just like a giant puffy marshmallow. At this point, the dough starts to feel what I call fragile, where like every time I'm touching this, it feels like I'm degassing it. So I'm trying to be super careful. See if I can get this out. Wow, that is really an airy loaf. In our droop test, you can see that is drooping much more than the other ones. That one's actually stretching in my hands. That loaf is losing a little bit of structure. But wow, that is a super aerated loaf. Look how that's sitting up in the pan. Super aerated. We'll see how this bakes up. This will be a real interesting one because that's got a lot of air. It's starting to push towards the right side of the Bulk-O-Matic indicators, indicating it could be overproofing, but the gluten strength is holding up tremendously well in that window pane. So this is just a peculiar combination of factors that I haven't seen before, so I'm glad we're doing this test. Let me just put the indicators up on the chart so you have this for the record, and you can see where this one is pushing to the right a little bit more than the prior ones. We're going to let this sit on the countertop for its 30-minute bench rest, and we will bake this up tomorrow and see how all these look. It's the morning of day 2. I'm preheating the oven. It's time to score and bake the loaves. Now I'll do this off camera in the interest of time. There's not a lot to see here until the loaves are baked. But just for the record, in case you're trying to replicate this process in your home, what I do is I preheat my Dutch oven in the oven to 500 degrees Fahrenheit, that's 260 degrees Celsius. I then put the loaf into the Dutch oven with the lid on. I reduce the temperature to 450 degrees Fahrenheit or 232 degrees Celsius. I bake it with the lid on for 20 minutes. Then I remove the lid, continue baking at that same temperature for 15 more minutes. These loaves typically bake up in about 35 minutes total. And if you recall, this was a 1,000-gram recipe divided into 4 small loaves. So these are 250-gram flour weight loaves each. They bake up in about 35 minutes, as I said. Each of these loaves spent 12 hours in the refrigerator. My refrigerator temperature is 36 degrees Fahrenheit or about 2.5 degrees Celsius. That's a pretty cool temperature. But if you saw from that chart yesterday, it takes almost 10 hours for the loaf temperature to get down to the refrigerator temperature. So there's still fermentation going on in the refrigerator in that cold retard. I put the loaves into the refrigerator at different intervals based on when they were done in bulk fermentation. I'm taking them out at the same intervals, so they all will have exactly the same cold retard time of 12 hours. After I take them out of the oven, I will cool them, and then we'll come back here and cut them open and inspect the crumb and see what we can learn about this experiment. The loaves have baked and cooled. Before we proceed, let me just recap the experiment. So the idea behind this was to try to replicate the tartine loaf bulk fermented at 80 degrees Fahrenheit, 27 degrees Celsius, typically for 4.5 to 5.5 hours, and a 30% rise in the dough. Now the idea was to replicate that type of loaf at a different bulk fermentation temperature of 70 degrees Fahrenheit or 21 degrees Celsius. So what we did was we baked 4 loaves, all bulk fermented at 70 degrees Fahrenheit, 21 degrees Celsius. We maintained that temperature really consistently throughout the process. And then we chose different percentage rises here to try to compare which percent rise at that lower temperature is the equivalent of the 30% rise at the higher temperature. So loaf number 1, we rose 30%, which is the typical guidance from Tartine. That bulk fermented in 9.5 hours. Loaf number 2 rose 50% after 11 hours of bulk fermentation. Loaf number 3, 75% rise after 12 hours of fermentation. And loaf number 4, 100% rise or a doubling in the dough after 13 hours of bulk fermentation. After these bulk fermented, they did a bench rest of 30 minutes, which is exactly the same as what we do in Tartine after we reach the 30% target. Then all the loaves went into the refrigerator for a 12-hour cold retard. My overnight refrigerator temperature was about 36 degrees Fahrenheit or 2.2 degrees Celsius. So this is a very controlled experiment relative to the time, temperature, and percent rise. And before we proceed, let me just remind you that these loaves had no pre-shaping and no final shaping. This is basically bulk fermented dough that I scooped out of the bulk fermenting bowl. I flopped it into a shaping basket. It sat overnight in the refrigerator. I scored it and baked it up this morning. It's extraordinary how good these loaves always look. I say this in every one of these videos. Bulk fermentation makes the bread. I mean, just look at this. Look at the ear, look at the height, look at the symmetry and shape of that loaf. It's just extraordinary that you can get that out of bulk fermenting dough with no shaping. Here's the shaping baskets that I use. Some people have asked how I do this. I basically use these loaf pans, but these are a little bit big if you're just doing 250 gram flour weight loaves, which is what these are. So I use these inserts. I just made these wooden inserts in my shop that just basically reduce this down into a rectangle. I'm not even using bannetons. It's basically a geometric type of rectangle. And then I put a tea towel in here with flour on that, and I bulk ferment them or cold retard them overnight in the fridge in those baskets. I flop them out in the morning, I score them, and this is what you get. It's amazing. So now let's just look at these from the top down and see what we have. Loaf number 1, 30% rise, 50% rise, 75% rise, 100% rise. You kind of see the progression that you would expect. The shorter bulk fermentation time, 9.5 hours, 11 hours, 12 hours, 13 hours. The loaf proofs less, it's more compact, a little bit tighter. When you get up here to 13 hours, 100% rise, the dough is a little bit more relaxed, the loaf is a little bit more relaxed. That's a typical pattern that you would expect and that we often see in these experiments. So let's look at loaf number 1. Loaf number 1, 70 degrees Fahrenheit, 21 degrees Celsius, bulk fermented for 9.5 hours, 30% rise in the dough. There's a gorgeous loaf. I mean, it's a little compact, but we got a beautiful ear there. Really nice shape to that loaf. But the one thing I'm a little concerned with here is that little bubble on the top. That ridge right there is sometimes an indication of underproofing, because you'll get a little gas bubble right under the bloom. This one looks a little bit under fermented to me, just looking at it from the top down, because it's kind of a compact loaf. Loaf number 2, this one really looks beautiful. This opened up a little bit more than loaf number 1. So a little bit less compact, beautiful ear, nice bloom on the ear there, beautiful symmetrical shape. That looks like a very nice loaf. That one rose 50% and it took 11 hours to get there. Now when we get into loaf number 3 and 4, as you can see from the top down here, these look a little bit more relaxed. They started to lose their shape a little bit, and you can really see that tight symmetrical shape of loaf number 1, which might be underproofed. As you get into more fully proofed loaves, the 75% rise and the 100% rise, that dough is relaxed a little bit more, and you see the way these are spread out around the midsection and a little bit oblong in their shape. So let's take a look at loaf number 3. This one is interesting. Again, really nice height, not as pronounced of an ear, and you can see on the top here, there was a little bit of a blowout in the skin, in the crust right there, which sometimes indicates that the dough is starting to overproof because you're getting a little bit of gluten deterioration. Loaf number 4 looks very similar to loaf number 3 to me. It actually has a little bit of a taller ear, but I'd say loaf number 4, that's our 100% loaf, doubled in size, really nice looking loaf right there. A little bit irregular shape, but not bad. The other thing you notice looking from the top down is the color, and this has to do with the amount of fermentation time. The longer you bulk ferment, the more sugars come to the surface of the loaf, and you get this Maillard reaction or this caramelization, that dark mahogany color on the loaves that bulk fermented longer. So you can see loaf number 1 is a little more blonde, loaf number 4 is a little more dark. These baked up in the same Dutch oven at exactly the same temperature, same time, same preheating time between each loaf. So I think this is literally due to a different chemical reaction in these loaves 3 and 4 because they bulk fermented longer and they darken a little bit because of that. There's an interesting kind of break point between loaf 2 and loaf number 3. So this is our 50% rise versus 75% rise, 11 hours versus 12 hours. And you can see loaf number 2 still remained really compact and symmetrical, which tends to show that that's more on the underproofing side. And then when the loaf gets relaxed, oblong, this bulge on the side, the tearing of the crust here implies that it's leaning towards overproofing. So there was definitely a break point here between the 50% rise and the 75% rise, or the 11-hour mark and the 12-hour mark at 70 degrees Fahrenheit, 21 degrees Celsius bulk fermentation. Let's see what these look like when we cut them open. So now it's time to cut the loaves. Before I do that, I just want to recap. The experiment was basically to find which one of these 4 loaves looks the most similar to the classic tartine loaf with the 80 degree Fahrenheit, 27 degrees Celsius bulk fermentation and a 30% rise in the dough. I know I've been talking about this the whole time and holding this book up and you're like, I don't know what he's talking about. Here's a picture of a classic tartine loaf, fully proofed, beautiful loaf. I've done this 100 times. This is from a prior experiment. This is what we're trying to match with the 4 loaves that we baked this morning. So you can see here just that beautiful shape, the ear opened up, really nice height, very consistent proofing, end to end, top to bottom, and a little bit of an open irregular crumb. That's kind of the classic tartine look that we're trying to find. Now that photo was from an experiment I just did a couple of weeks ago. So these loaves are literally exactly the same flour, maybe even the same bag of flour, the same water, the same Dutch oven, the same lineage of starter. These are as close to an exact comparison of loaves as you can get. Let's cut open loaf number 1 and take a look. So this one rose 30%, the same as the tartine loaf, but this went for 9.5 hours of bulk fermentation versus typically 5.5 hours for the tartine loaf. And this bulk fermented at 70 degrees Fahrenheit versus 80 degrees Fahrenheit, or 21 versus 26 degrees Celsius. Let's see what the crumb looks like. Now that is a pretty nice crumb. It's slightly underproofed, but not bad. When I see these kind of vertical bubbles coming up here off the bottom, that implies a little bit of underproofing, but really not bad. That is actually a pretty nice, very similar classic tartine loaf to what I would get before, just a touch underproofed compared to that benchmark loaf that I just showed. So this is really interesting because basically we're saying that a 30% rise at 80 degrees Fahrenheit is very similar to a 30% rise at 70 degrees Fahrenheit if you just give this enough time, 9.5 hours versus 5.5 hours. It got pretty close, but not quite exact. Let's see what the next one looks like before we make a call. Here's a more detailed look at that crumb if you want to pause here. Loaf number 2, 50% rise, 11 hours bulk fermentation at 70 degrees Fahrenheit, 21 degrees Celsius. This is a little bit taller loaf, a little bit more air as I'm cutting through it. Now ignore that big air bubble at the bottom because we did not do shaping of these loaves. You're going to get some air bubbles like that. Now this one is more proofed than the prior one. You can see that I don't have those big vertical tunnels coming up from the bottom. That's a pretty good looking loaf. I think that actually looks very similar with the exception of that air bubble to the benchmark loaf, really close. So this is basically a 50% rise in the dough that I think is closer to the tartine 30% rise. This one went 11 hours versus tartine 5.5, so roughly double the time at 10 degrees less temperature Fahrenheit, 6 degrees less Celsius. Here's a more detailed look at that crumb if you want to pause here. Loaf number 3. This one looks a little more relaxed to me, feels a little softer to the touch. Let's see what it looks like. Really nicely proofed loaf. Now that, again, I got a big air bubble here, ignore that. That's what I would call a fully proofed loaf, where you've kind of gone past that open irregular crumb, and now you're really getting a little bit more dense crumb, top to bottom, side to side. This is just past the point of what I'd call fully proofing, heading towards overproofing. This is kind of fully proofed plus, if I had to put a name on this. So this is what a 75% rise looks like at 12 hours of bulk fermentation. As I look at this actually looks very similar to an 80-degree Fahrenheit tartine loaf at a 40% rise. Looks very similar to the 70-degree Fahrenheit loaf with a 75% rise. So I'll see if I can find a picture. Here's a picture of that loaf I was referring to. This is a 40% rise tartine loaf versus the 75% rise at 70 degrees Fahrenheit. That's a great comparison. Here's a more detailed look at that crumb if you want to pause here. Loaf number 4. Very fully proofed loaf. Again, pushing up to the edge of overproofing, but I wouldn't call this overproofed in any way, but you've lost that open irregular crumb. You have a much more dense crumb throughout. So this is again what I would call a fully proofed plus. This is pushing up against overproofing, but not really, you can't really call this overproofed because it kept its shape beautifully, but you can see the real dense cells here, which imply that this is kind of past its prime. Some people like a really fully proofed crumb like this, but we're trying to compare this back to that classic tartine open irregular crumb. This is really fully proofed plus, similar to loaf number 3. So this is the 100% rise or the doubling of the dough, and this gives you a very fully proofed loaf, but still a very nice shape to it. Here's a more detailed look at that crumb if you want to pause here. Now this 100% loaf at 70 degrees Fahrenheit looks a lot to me like a 60% rise loaf under tartine. You really need a photographic memory to do this. I hope I can find the pictures that match this. So I just jotted down my notes here based on my initial reaction to these loaves, and it's fascinating because I'm comparing in my mind to the 80 degree Fahrenheit, 27 degree Celsius tartine loaves as my reference point. So let me just lay these out and I'll see if I could put these into a chart. So I went back to some prior videos and photos and I essentially found pictures of loaves that look exactly like the 4 loaves that we baked today using the standard tartine method for those prior loaves. And based on those details, here's how they compare. So for today's loaves, which you see in the left-hand column, our 30% rise loaf today looks like a standard tartine loaf with a 25% rise. Our 50% rise loaf today looks like a tartine 30% rise. Our 75% rise loaf today looks like a 40% tartine rise. And our 100% rise loaf today looks like a 60% tartine rise. And then in the third column, you see the difference in the number of percentage points between those two values. So let's go to the next page. And what this shows is the data points now plotted on the 2 lines. The blue line are today's 4 loaves with their percent rise. And then the red line are essentially the matching crumb photos and looking at what percent rise in those tartine loaves got the matching crumb to today's loaves. So here you can see the difference between those 2 charts grows as the percent rise grows. It becomes a wider variance. But the fact that there is a significant difference between the blue line and the red line is a proof of our Linguini test that basically says the blue line, the cooler bulk fermentation temperature, requires a higher percent rise to deliver the same results versus the red line, which is the warmer bulk fermentation temperature. That's because, as we discussed, in that red line, the gluten matrix is relaxed. So it's sitting down in the bowl. It's not rising as much. The protease enzyme starts to deteriorate the gluten. And the third factor is because the loaves continue fermenting after you finish bulk fermentation. So that gap continues to close slightly when you're bulk fermenting a warmer loaf versus a cooler loaf. And then lastly, on this page, I just summarized the percent rise and the bulk fermentation times for the 8 loaves that I'm comparing. So these are the 4 loaves. Now I sliced 4 slices out of each one to see if there was any more story to tell in the crumb. And all I can say is, wow. These loaves look spectacular, all 4 of them. Just amazing. And But let's just recap how wide of a variation there was in time and percent rise. 9.5 hours, 11 hours, 12 hours, 13 hours. That's a 4.5 hour difference between this loaf and this loaf. I mean, it's unbelievable how similar those are. So working at this low temperature, you have a massively wide margin of error in really trying to catch the end of bulk fermentation. You have a 4.5 hour difference between loaf 1 and loaf number 4. It's unbelievable. And then when you look at the percent rise, 30%, 50%, 75%, 100%, the difference between a 30% rise and a 100% rise, I mean, I can definitely see the difference here, but that is really an extraordinarily tight band of how the crumb looks. Now, if I take a more critical look at this, kind of going left to right, as I said when we looked at the outside of the loaves, there's definitely a break point between loaf 2 and loaf 3, where you go from this open irregular crumb on loaf number 2 to this more dense kind of honeycomb style crumb on loaf number 3, which to me implies that you're heading into overproofing territory. But the difference between these loaves, these low temperature loaves at 70 degrees Fahrenheit, 21 degrees Celsius, is overproofing is creating a little bit of a dense crumb here, as you see in this one and this one, for example. But it's not really deteriorating the loaf the way that you get overproofing at a warm bulk fermentation of 80 degrees Fahrenheit or 27 degrees Celsius. At a warmer temperature, you get that protease enzyme effect where these, what I'd say, overproofed loaves really start to deteriorate in terms of the gluten structure. The loaves will flatten, the crumb will change its texture significantly differently from these. Here, because we're bulk fermenting at a lower temperature, you keep the protease enzyme at bay, you don't get the gluten breakdown. It's as simple as that. You could have probably gone past 100% and still had a decent looking loaf. That's the Ken Forkish recipe where he recommends a 200% rise or tripling in size of the dough. I can see that now because at that low temperature, you just don't risk the gluten deterioration. So we have completed a taste test of the 4 loaves. I've tasted them all, and I employed the services of an independent judging panel. That would be my wife, who also tasted them all. She tastes all my bread. Both of us really came to the same conclusion, that among these 4 loaves, there was really no difference among the 4. 30% rise tastes the same as 100% rise. 9.5 hours of bulk fermentation tastes the same as 13 hours of bulk fermentation. That's not uncommon in these taste tests. Normally the variations in bulk fermentation time really don't produce a lot of flavor differences. Comparing this to the other loaves, it was very difficult to really put our finger on that without doing a side-by-side comparison at the same time. I'm kind of going from taste memory, if you will. But to me, the tartine loaf had a slightly more wheat forward flavor than these loaves. These tasted incredibly mild to me. And you know, these also had a 12-hour cold retard, which is typical with what I do with tartine. And these might have had a slightly brighter acidic tang to them than the tartine loaves. But like I said, we really need to do a side-by-side comparison to be certain. So when I think about bulk fermenting at 70 degrees Fahrenheit versus 80 degrees Fahrenheit, it's not just a difference in the temperature. It's a whole different style of baking sourdough. This is an entirely different style of making sourdough than I've done in the past, where I was always at higher temperatures. This is easier, it's slower, and it's much less risk. Now, I've also bulk fermented at 90 degrees Fahrenheit or 32 degrees Celsius because I try to create tools for warm weather bakers, people who are trying to bake in the summer, people who live in warm climates year round. 90 degrees Fahrenheit is a whole nother level of extreme. So what I did was I put this chart together that I call the 70, 80, 90 model, and this is in Fahrenheit because in Celsius this would be 21, 27, and 32, which doesn't quite roll off the tongue as easily. So stick with me on this one for the people who don't use Fahrenheit, the 70, 80, 90 model. So I really describe these as 3 completely different baking styles. This isn't just a small tweak of the temperature. There's a step function here when you go from 70 to 80 and 80 to 90 in terms of the way that you're baking or bulk fermenting the loaves. So I just put a couple of categories down here, and let me just walk through these. The first one is that what I call the risk rating is that if you're a beginner and you're trying to figure out how to bake bread, at 70 degrees, it's like riding a bicycle, 80 degrees is like riding a motorcycle, and 90 degrees is like speeding on a motorcycle with no helmet. So next one I talk about the baking style. The 70-degree loaf is kind of a walk-away loaf. You mix the ingredients and you disappear for 8, 10, 12 hours. That's a real typical overnight type of recipe. For the tartine method, you're typically using a proofing chamber to try to keep your temperature at that 80 degrees Fahrenheit. So that's what I call an attended style baking. You can't really walk away from a tartine bulk fermentation. You have to kind of stick with it. And then for the 90-degree baking, that is really a close monitored bulk fermentation where you're literally watching that in 15-minute increments. And I've done it before. It's very challenging. And then I show the time ranges here where you have to have that contiguous bulk of time to finish bulk fermentation. That's the challenge with the 70-degree bulk fermentation, is if it's going to end 14 hours later, you have to make sure that you're not sleeping or you're not at work or you're not away. So you have to really time that big window to be able to make sure that you're around for the start time and the end time. It's the only thing tricky about this, but it really lends itself to overnight. The risk of overproofing with 70 degrees is extremely low. I mean, I would have to try very, very hard to overproof this loaf. I don't know how far I would have had to go. Overproofing risk with tartine is pretty moderate, which I say, 25, 30% of the time, you can overproof that loaf by accident, really, even if you're good at it. And then at 90 degrees Fahrenheit, the overproofing risk is extreme. I've done that before. Underproofing risk with this loaf, I would say, is moderate. And some people might look at this and say, well, that's not symmetrical with the overproofing, because shouldn't it say that the risk is high, where we'd expect it to go high, moderate, low? There's not a high risk of underproofing this because all you have to do is look at the dough. I mean, it's not that complicated. If the dough hasn't risen, keep going. The risk of underproofing tartine seems to be about the same. You really have to rely on that percent rise, and anything below 30% rise is going to underproof. So that's fairly equivalent. Underproofing on a 90-degree loaf is low just because it proofs so fast. So then you talk about the margin of error, which means if I'm really trying to catch this exactly at that end of what I see here in loaf number 2, which is my desirable endpoint, my margin of error is plus or minus 2 hours. I'm really not going to screw up the loaf if I'm an hour earlier or 2 hours later. There's a wide margin of error around this. With tartine, that margin of error is about 30 minutes. You can see that in episode 1 of this series where I do 30-minute cutoffs, and the nature of the crumb changes materially when you're bulk fermenting at 80 degrees. And at the 90-degree loaf, that margin of error is 15 minutes. Literally, the loaf can change that quickly. So then when you think about the total time required, the 70-degree baking, even though it's easier, it requires 2 or more days. You really can't do this as a same-day loaf or even as a 1.5-day loaf. It's pretty much a full 2-day process. With tartine, you can do that in the same day. You can do a same-day loaf, or you can do an overnight cold retard and be a day and a half later. And then with the 90-degree loaf, similarly, that's a 1 to 1.5 or 2-day loaf. And the skill level, 70 degrees Fahrenheit, a beginner can do this. Mix the ingredients, watch the dough, try to pick some point between a 30% rise and 100% rise. It's not very difficult, and you get a pretty good looking loaf. That's what I would call beginner level skills for sourdough. Tartine is moderate level skills because you have to catch that cutoff point a little closer, and baking at 90 degrees or bulk fermenting at 90 degrees Fahrenheit is expert level because you're down in 15-minute increments with massive risk of overproofing. Bulk fermenting at lower temperatures is a lot easier than bulk fermenting at higher temperatures. It's much harder to screw it up. I mean, there's a 4.5-hour difference between these loaves, and they all look pretty good. There's a 70% difference in the percent rise. They all look pretty good. You have nowhere near that level of latitude when you're bulk fermenting at 80 degrees Fahrenheit or 27 degrees Celsius. Things would go south in a hurry. So this has really been a revelation to me, because I've bulk fermented some loaves at 75 degrees Fahrenheit or 24 degrees Celsius, and that's not materially different when compared to bulk fermenting at 80 degrees Fahrenheit. That extra 5 degrees, when you get down to 70 degrees Fahrenheit, 21 degrees Celsius, everything just kind of slows down. It's a lot easier, it's less risky, it's much harder to screw it up. So if I were a beginning baker or advising beginning bakers, I would definitely recommend starting with some of these cooler bulk fermentation temperatures, what I call the low and slow method. 70 degrees Fahrenheit, but it might take 10, 12, 14 hours for the loaf to finish bulk fermentation. That's really the only downside of using those recipes, is I feel like they're a little bit less predictable in terms of the timing, because you have to wait an hour to get from this loaf to this loaf and an hour to get from that one to that one. So if you're really trying to fine tune your crumb and find that perfect cutoff point, it's a little more difficult because it's in a much wider window of time. But conversely, if you're just trying to get a decent crumb, you have a massive window. I mean, you could, over a 13-hour bulk fermentation, you have a 4.5-hour window at the back end of it to catch any one of these 4 loaves, which are perfectly acceptable loaves. So what's the bottom line? What did we learn in this video? At the beginning of the video, we asked the question, how can some recipes call for a 30% rise and other calls for 100% rise, and they both come out the same? The difference is the bulk fermentation temperature. When you're bulk fermenting at lower temperatures, 70 degrees Fahrenheit, 21 degrees Celsius, the dough can handle a much higher percent rise because you don't get that softening or relaxation of the gluten, so that architecture of the gluten will stand up taller, as we showed in the Linguini test. And the second thing is that when you're bulk fermenting at lower temperatures, you have much less risk of stimulating the protease enzyme, which starts to break down the gluten, and it'll cause the loaf to start to collapse at the same time that you're trying to rise the loaf. So warmer dough will generally just be flatter than cooler dough during bulk fermentation for those 2 reasons. The other reason that some recipes call for a lower percent rise is because you have to consider what happens after the cutoff for bulk fermentation. And this was a great example with Tartine, where we cut off bulk fermentation at a 30% rise because there's a 30-minute bench rest between pre-shaping and final shaping at 80 degrees Fahrenheit. And then the loaf goes into the refrigerator for the cold retard at 80 degrees Fahrenheit. It takes an hour for that temperature in the refrigerator to get down to 70 degrees. So just those 2 factors alone are essentially adding 90 minutes of fermentation time at the 80-degree warm temperature, 27 degrees Celsius, with Tartine, versus a 70-degree loaf that would say at the end of the 70-degree bulk fermentation, you just shape it and put it into the refrigerator with no bench rest, and it goes into the refrigerator at 70 degrees Fahrenheit. You've shortened that bulk fermentation time by 90 minutes by comparison to Tartine. So the early cutoff in the Tartine method is what I characterize as you're trying to stop a speeding train. Because it's fermenting very quickly at that warm temperature, you have to cut it off early because it's going to keep fermenting at that temperature before the refrigerator temperature gets it down into the point where it's retarding the fermentation. And then lastly, bulk fermenting at 70 degrees Fahrenheit, 21 degrees Celsius. I originally thought that this was just going to be some formulaic tweaking of the temperature charts. It's really not. It's a completely different style of making sourdough bread. It just behaves entirely differently because you don't get the gluten deterioration during bulk fermentation that you see at warmer temperatures. So it gives you a massive window to complete bulk fermentation in, and it gives you a huge margin of error around the edges of what you're trying to achieve, because it's extremely difficult to overproof a loaf at 70 degrees Fahrenheit, and it's difficult to underproof a loaf at 70 degrees Fahrenheit because the dough just won't rise. If you at least wait for the dough to rise to 30%, for example, it actually produced a pretty good loaf. So bulk fermenting at lower temperatures is just another tool in your toolkit as a sourdough baker. It just gives you another way to bake bread, another way to modify your schedule, and a way to de-risk your baking, just to make it a little bit easier on yourself and still produce fantastic bread. Thank you for watching this video. Now I am going to eat some bread.